What is machine learning? Machine learning is a field of artificial intelligence that uses statistical techniques to enable computer systems to learn from data and make predictions or decisions without being explicitly programmed. What are the types of machine learning? There are three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. What is supervised learning? Supervised learning is a type of machine learning where the algorithm is trained on a labeled dataset, meaning the data has a specific target value or output variable that the algorithm is trying to predict. What is unsupervised learning? Unsupervised learning is a type of machine learning where the algorithm is trained on an unlabeled dataset, meaning the data has no specific target value or output variable that the algorithm is trying to predict. What is reinforcement learning? Reinforcement learning is a type of machine learning where an agent learns to make decisions in an environment by receiving feedback in the form of rewards or punishments for each action taken. What is the difference between supervised and unsupervised learning? The main difference between supervised and unsupervised learning is that supervised learning is trained on labeled data, while unsupervised learning is trained on unlabeled data. What is overfitting in machine learning? Overfitting is a common problem in machine learning where a model is trained too well on the training data and performs poorly on new, unseen data. What is regularization in machine learning? Regularization is a technique used to prevent overfitting in machine learning by adding a penalty term to the loss function. What is the difference between classification and regression in machine learning? Classification is a type of supervised learning where the goal is to predict a categorical variable, while regression is a type of supervised learning where the goal is to predict a continuous variable. What is gradient descent in machine learning? Gradient descent is an optimization algorithm used to find the optimal weights or parameters of a machine learning model by iteratively adjusting them in the direction of the negative gradient of the loss function. What is the difference between population and sample in statistics? A population is the entire group of individuals, objects, or events that you want to study, while a sample is a subset of that population. What is the central limit theorem? The central limit theorem states that for large sample sizes, the sampling distribution of the mean of a random variable will approach a normal distribution, regardless of the distribution of the variable in the population. What is the difference between a t-test and a z-test? A t-test is used to test the significance of the difference between means of two samples when the population variance is unknown, while a z-test is used when the population variance is known. What is the p-value in statistical testing? The p-value is the probability of observing a test statistic as extreme as or more extreme than the one calculated from the data, assuming the null hypothesis is true. What is regression analysis? Regression analysis is a statistical technique used to model the relationship between a dependent variable and one or more independent variables. What is correlation analysis? Correlation analysis is a statistical technique used to measure the strength and direction of the linear relationship between two variables. What is the difference between correlation and causation? Correlation refers to a statistical relationship between two variables, while causation implies that one variable directly causes the other. What is ANOVA? ANOVA, analysis of variance, is a statistical technique used to test whether there is a significant difference between the means of two or more groups. What is the difference between a type I and type 2 error? A type I error occurs when you reject the null hypothesis when it is actually true, while a type 2 error occurs when you fail to reject the null hypothesis when it is actually false. How do you evaluate the performance of a machine learning model? I evaluate the performance of a machine learning model using metrics such as accuracy, precision, recall, F1 score, and area under the receiver operating characteristic (ROC) curve. I also use cross-validation techniques to estimate the model's performance on unseen data. Can you explain the difference between a decision tree and a random forest? A decision tree is a type of model that makes decisions by recursively splitting the data based on the values of input variables. A random forest is an ensemble method that uses multiple decision trees and aggregates their predictions to improve performance and reduce overfitting. How do you handle imbalanced datasets in machine learning? Imbalanced datasets can lead to biased models, as the model may be more accurate in predicting the majority class. Techniques for handling imbalanced datasets include oversampling the minority class, undersampling the majority class, and using cost-sensitive learning algorithms. Can you explain the difference between batch and online learning? Batch learning involves training a model on a fixed dataset, while online learning involves updating the model continuously as new data becomes available. Batch learning is typically used for offline data analysis, while online learning is used in applications such as fraud detection and recommender systems. How do you handle missing or corrupted data in a dataset? I handle missing or corrupted data in a dataset by imputing missing values, removing outliers, or using data augmentation techniques. Imputation methods include mean imputation, regression imputation, and k-nearest neighbor imputation. Can you explain the bias-variance trade-off in machine learning? The bias-variance trade-off is the balance between a model's ability to fit the training data and its ability to generalize to new, unseen data. A model with high bias is too simple and underfits the training data, while a model with high variance is too complex and overfits the training data. Finding the right balance is crucial for building a good machine learning model. Can you explain what regularization is and why it is important? Regularization is a technique used to prevent overfitting in machine learning models. It involves adding a penalty term to the objective function of the model, which discourages the model from fitting the training data too closely. Common types of regularization include L1, lasso, and L2, ridge regularization, which penalize the model for having large coefficients. Regularization is important because it helps to improve the model's generalization performance and prevent overfitting to the training data.